Datex, confirm our current position.
Geosynchronous orbit above Neptune's upper troposphere. Altitude 55,000 kilometers. Velocity 24,000 kilometers per hour. Radiation shield holding. Hull temperature -175 degrees Celsius and dropping.
Alright, let's get those diamonds.
Reminder, atmospheric entry is ill-advised. Neptune storms make Jupiter look like a summer breeze.
Now begin the environmental scanning. I do need the complete information before we go for fishing.
Atmospheric conditions as follows. Pressure, over 1 million times Earth's surface pressure. Temperature, -220 degrees Celsius. Wind speeds, sustained at 200 kilometers per hour, with jet streams reaching 2,100 kilometers per hour. Chemical composition, hydrogen, H2, helium, He, methane, CH4. Corrosive environment confirmed.
What's the chances for structural failure?
Our base station would collapse at 0.1% of the existing pressure. The propulsion system cannot stabilize against lateral wind shear. Worse, methane and hydrogen will corrode the thruster nozzles and outer panels.
Now there has to be a workaround. We did not travel 4.5 billion kilometers just for duck and tail, right?
Recommendation, full retreat. Attempting harvest is suicidal.
We don't need a full harvest. We just need a handful. What if we just run a small scale test,
Retracting previous alert, attempting robotic arm deployment to collect samples. Caution, atmospheric turbulence increasing. Hold duration must not exceed 90 seconds.
Understood. Now let's bring home something shiny. Actual diamond rain. Looks like thousands of carats falling like snowflakes. Wow.
Sample secured, retracting arm. Recommend immediate retreat.
One last thing before we go. How much energy we can really pull from this? Any idea?
Diamonds are carbon atoms in tetrahedral crystalline lattice. Oxidation formula, C plus O2 to CO2 plus energy. Energy released per mole, 394 kilojoules.
Right. Now, let's say one handful is equivalent to 1 mole. Now, you tell me that how much handful amount we require to get to the required number of power that we need.
Calculating. Total energy required for long-range jump, 10 to the 46th power joules. Number of moles needed equals 10 to the 46th power divided by 394,000 equals approximately 2.54 times 10 to the 40th power moles. Mass equals 2.54 times 10 to the 40 power moles times 0.012 kilograms per mole equals 3.048 times 10 to the 38th power kilograms. Convert to Earth masses. 1 Earth mass equals 5.97 times 10 to the 24th kilograms. Earth mass equivalence equals 5.1 times 10 to the power of 13 Earths.
So calculating the number, I think it would require 51 trillion Earth worth of masses of diamond. That's a crazy. And that also for just to achieve just one process, right?
Affirmative. Current technology is insufficient. Even harvesting 1/1,000,000th of this would require planetary scale infrastructure and centuries of mining.
That's not just impossible. I mean, it's a mythic.
Suggest alternative strategies. Solar extraction, quantum vacuum decay, antimatter harvesting.
So that is, while I stare at the diamonds, let us not jump to a conclusion. Let us first store them study the energy levels and also study the structural properties. Maybe we can get something out of it.
Red alert, jet stream approaching. Time to leave, now.
Full thrust, get the 30-degree elevation and get the hell out of here.
Query, what substance are you ingesting?
Space whiskey helps me think.
Alcohol impairs cognitive efficiency.
That is, I think we're thinking a bit crazy because we need to think outside of the box. We can suppress the lattice of the diamond crystals and take more energy out of that using microfusion. We can even play with the alteration of the molecules and the atomic particles by which you can harvest more energy from its isotopes. I think we should just think outside of the box.
Logging irrational but potentially creative hypothesis.
One small scoop of impossibility might unlock door to some new possibilities. And if it doesn't,
Then we at least made history.
cheers to that.